Okay, folks, we are on the second to last mini lecture of this chapter. It's a short week because you have a big exam. So the last thing the chapter talks about is that mutualisms scale up. Right? We've talked about this. This should not be news to you, right? One of the things that I think is really critical here is often textbooks break mutualism apart from parasitism, apart from competition, apart from consumption. But in general, they're all interactions. And they happen on a continuum, right? A continuum of outcomes for species. And in some cases, these interactions are negative, more negative, very negative. In some cases, they have no effect on each species. In other cases, they have really high positive effects. And so just like we learned, for example, in the landscape of fear, how predation can scale up to shape the distribution of plants, right? Where wolves scare off herbivores, and those herbivores eat less of the plants and allow new plant communities persist. In the way that that interaction, that pairwise interaction between predator and prey, can scale up to shape the distribution and density of species, mutualisms can do the same, right? Because they're not any different. They're also interactions that have outcomes. And because they're net plus interactions, they increase population growth rates. That's the definition, right? If the mutualism is positive for most of the individuals in a population, the population growth rate is going to go up, right? Because it increases their fitness. And so these interactions, these positive interactions, just like negative interactions, can shape which species persist in a community, which species reach dominance. They can even limit the ranges of species. So imagine a situation, and this is quite common now, where we have plant species moving across a landscape, right? Plant species are moving across a landscape, and their mutualists are moving across a landscape. Imagine a mountain, right? Here's a mountain. And we have a species of flower that occurs at mid-latitude. Here's our happy little flower. And it loves mid-latitude because at the right time of year, when the sun gives it enough light and the temperature is just perfect, it can do all of its life history processes and reproduce. And through thousands of years of coevolution, a bee has also evolved temperature cues that help it know when to come out, right? And in this case, they can both come out together and persist. The bee gets food, we get a nutritive mutualism, we get a service mutualism, both species persist. But now imagine the climate is warming. What's going to happen, right? We know that if you paid attention in the first couple lectures, that as we go up in elevation, it's like going up in latitude, it gets cooler, right? And one of the things that's happening is species, there's very good evidence for this, species are moving upslope as the climate warms. So we have plant species moving upslope, we have animal species moving upslope. But as you can imagine, sometimes animals are much more mobile, right? Sometimes plants are much more mobile. Sometimes there's ecological factors that make it so that animals can't move. For example, nesting sites if you're moving above tree line or something like that. And so you can imagine a situation here where that mutualism, the interaction between the plant and the pollinator, the exchange of nutrients for services, limits the range of the plant. Let's say the plant can move upward, right? The plant can move upward, but the pollinator nests in trees, and as soon as the plant gets above tree line, there are no more nest sites. So the pollinator can only move to here, right? It's limited here. Do you think the plant will persist in these populations where the mutualist can't? The answer is probably yes, because most mutualisms are diffuse and there's other partners around. But if this were an obligate mutualism, the range shifts of the pollinators could limit the range shifts of the plants. And this is the basic process that is happening all the time, right? There are mutualisms, antagonisms, these are the other word for negative interactions, shaping where species persist on the landscape, and relative competitions between species, right? And so this is one of the ideas is that interactions scale up here. Interactions scale up. I'd love you to read the examples in your book for this. I'm not going to go through a bunch of case studies there because I'm going to do one more mini lecture here talking about mutualistic networks. And this is some work that's really common in our department. We have a bunch of faculty that think about mutualistic networks and really, I think, puts the idea that mutualism scale up to ecosystem processes in perspective. So I'm going to give you a little case study there and tell you a little bit about mutualistic networks, and then we are finished. Thanks for sticking with me.